Hello and welcome back to another episode of Teardown Tuesday. Today we're taking a look at a pump housing, and this pump housing is pretty big for my teardown space, but I'm going to try and make it work. I've got some other stuff on the big bench today. So the first thing is, what is this? And you can see here we've got a pump housing on this end, we've got a drive motor on this end, and the entire assembly is designed to pull water in down here on the inlet and then push that water back out the outlet over here. When this motor is installed, our water feed would go in this impeller and then be forced out this outlet. And there would be some kind of fitting or tank bolted to this face. The motor itself is a pretty straightforward motor. It's either 208, 230, or 460 three-phase in this case. And something to note with the motor, when you go to install this, you will have to wire this accordingly depending on what voltage is being supplied. And typically they're going to come wired for the higher voltage. So if you just hook it up and you don't check, you don't blow up the motor windings. The way that we would know which way to wire it is a sticker down here. And you can see this is the low voltage side and this is the high voltage side. And they show you how to bridge the different wires together. The wires that are inside here will have numbers on them, and depending on those numbers you either tie them together and bridge them, or you bridge them to each other. So you can see for low volt we'd bring our line voltage to 9 and 3, 8 and 2, 7 and 1, and then tie 6, 5 and 4 together. In a high voltage, a 460, 480 volt, we'd bring our line voltage on 1, on 2, and on 3, and then we would tie 4 and 7, 5 and 8, and 9 and 6 together. Down here on the end, the motor has this hex, and this is here entirely to help you free this up if it were to become jammed. So let's go ahead, I'm going to pull this housing apart and let's see what we can do here. So now that we've got this opened up, you can see the impeller really clearly, that complex shape of the impeller. And you can see the inner housing here. It's interesting to note the shape is so complex and it's such a tight fitting tolerance that our gasket assembly is actually a stack of several gaskets. Because we have several gaskets here, we can shim to make sure we have the right amount of clearance between the end of this rotor and this face. If we get it too tight, it'll jam. If we get it too loose, we won't get enough pressure out of our pump assembly. But you can see there's not much else inside this part of the housing. The interesting part is back here, the seal. So let's get to that real quick. Looks like we're going to need a puller. Get that out of there. Wow. You can see we've totally pretty much destroyed this wheel now, this pump impeller. And I'm taking a look down inside there just to see if there's something I missed, but there's not. That's kind of wild. There's not really anything in there retaining this except maybe some rust at this point. There's no other set screw or anything that I can see. Let's try it again. Unfortunately, that wasn't the wheel coming loose. That was just the puller off-centering the head of the bolt that we've got in that shaft. We've put a huge amount of force on that and it's not come loose. The only thing that I can think of to do here is put heat to it. I'm sort of shocked at how much force it's taking to get this thing free. You know what? I have totally screwed this up. This is probably threaded on, and I have probably just completely destroyed it. I should have known from the squared off tip. Yeah, look at that. Well, let this be a lesson to you. Don't put pullers on things until you're sure it's not threaded. I think I've managed to actually bend the end of this motor shaft. Wow, made a huge mess out of this one, folks. Yep. So I twisted the end off the motor shaft. Serves me right. Caused all this myself. But hey, at least now we get to see the seal. Small graces. Let's go ahead and see if we can get this entire housing apart. Yep, so there's where the shaft twisted off. And there's our seal. Let's get this motor out of the way now. And if we take a look back here, you can see this housing is machined smooth. The seal itself is down inside there. And it's a press fit from this side. We've got a plastic or soft rubber around the outside. And then we've got this white material on the inside. And that white material is actually a ceramic. So the way this seal goes together, these ceramic surfaces press up against each other and they're perfectly smooth. Creates a watertight seal, which is really impressive. The downside to this type of seal is that it's very brittle because it's so hard. So any kind of prying force against it will usually chip it. And if you aren't careful with it, you get some kind of debris on this surface, it won't seal. And you can see this one has a little bit of marring on it. Some of that's probably from me heating it with a torch. But that's our seal assembly. Very interesting, very reliable when they're installed correctly, but very interesting little seal assembly. So with a pump like this, when we talk about principles of operation, we're rotating this rotor assembly, or what's left of it, inside a sealed housing with seals on all the inlets, outlets, pass-throughs, and we're creating that pumping motion. Really what we're doing is creating a pressure difference. We're creating a low pressure on the inlet and a high pressure on the outlet. If you run these backwards, a lot of times they will still pump, but they'll make a terrible noise and they won't pump very well. So with the three-phase in particular, you want to make sure it's running the right direction. When we talk about how it could fail, you could try and put a puller on it. That would cause it to fail pretty expensively. You could have a seal failure, which is probably the most common back in here. And these materials will break down over time, especially the rubbers in here. You're dealing with hot water, it's got chemicals in it, it's got cleaners in it. It's a pretty harsh environment. Other ways it can fail is it can draw in debris. If something gets in this inlet, because it's such a tight fit to this rotor assembly, impeller, anything that gets in there will jam it up. And I've seen everything from silverware, like forks and table knives, to a dough scraper, those plastic wedges that you use to rotate around a bowl when you're cleaning out dough and icing. I've seen those get down in here and they'll jam up in the inlet, and either the pump won't start or the pump won't pump any water because it'll pull that thing in the inlet and that'll block the water flow. Other failures you might see are just leaks. This whole outer leak path here is sealed up by these spacers, these gasket spacers. And it is possible over time you could develop a leak from those too, although they tend to be pretty reliable. Motor failures are also possible, electrical issues. Three-phase motor, if you were to have a bad connection or lose one of the phases, that would cause the pump to not run. It wouldn't have any starting torque, and that could be an issue as well. So I guess that's it for now. I mean, it just goes to show you, everybody can make mistakes, and what we do isn't easy. So, at least you can learn from mine. check and make sure the shaft is threaded before you put a puller on. Expensive mistake in the field. Thanks for watching. I'll see you next time. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for Smartcare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at Smartcare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a Smartcare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a Smartcare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.